to part 2 of solving radical equations. In the first part, I gave you a pretty simple example, but in this example, notice that we've isolated the radical and it's equal to x minus 4. Now we're still going to be taking a square root graph and intersecting it with a line. Right? That hasn't changed. But when we solve this algebraically, we're going to have a little bit more of a task to complete. So I'm going to start, just like I started the other question, by squaring both sides now that the radical is isolated. Remember, the square and the square root are inverses of each other, so they're going to cancel each other out. So we have x minus 2. Here's the part where I really want to emphasize. Remember that x minus 4 squared is really x minus 4 times x minus 4. So we actually have to multiply those out. So you might like to use the box to do that, or FOIL. I'm going to use the box. That gets us x squared minus 4x minus 4x plus 16. So I'm just going to combine my like terms. So look at the right side of our equation. We have x squared minus 8x plus 16. Notice this is a quadratic equation. I'm going to set it equal to 0. So I'll minus x on both sides and add 2 to both sides. That would leave us with 0 equals x squared minus 9x plus 18. There's a few different ways that you could solve quadratics. If it's factorable, I think that's the easiest way to go. So I'm going to check and see if this one's factorable. Do any numbers multiply to 18 but also add to negative 9? So 6 and 3 multiply to 18. To make them add up to negative 9, we could use negative 6 and negative 3. So that's what I'm going to use. X minus 6 times x minus 3. And now that that's set equal to 0, here we would know that x would equal positive 6, or x would equal 3. But I'm going to do something to show you something weird happened. I'm going to do a quick sketch of the situation. So the first graph is a square root graph that got moved right to. Yeah, I'm just doing a really quick sketch here. And then the x minus 4 has a y-intercept at negative 4 and a slope of 1. So it looks something like that. How many intersection points do you notice? I only see 1, which means that one of these answers is correct and the other is not. So I'm actually going to substitute them or plug them back into this equation and see which one is going to work. So I'm basically doing a check, but I'm not checking to see if my work is correct. I'm checking to see which answer is actually a real answer. So let's check the 6. Square root of 6 minus 2 equals the square root of 6 minus 4. Remember, I'm using it in the original equation. So I got the square root of 4 equals 2. Yep, that's true because 2 equals 2. Great. I believe that x equals 6 is a real answer. Next check. Just to show that this one doesn't work. We don't think it's going to work. The square root of 3 minus 2 equals 3 minus 4. Remember, we're asking ourselves, does it equal? Here you'd get the square root of 1 equals negative 1. But that's not true, because the square root of 1 is 1. And 1 does not equal negative 1. So I'm going to cross this answer out. I'm going to write down that it's an extraneous, where there's extraneous solution. Basically means an extra solution. The quick explanation of, well, why did you get an extra answer? Notice that you started with a square root equation, but you wound up solving a quadratic equation. Quadratic equations always have two answers. Radical equations don't. Okay, so that's why. Let's do another one for practice. Okay, so we have this square root. Remember, you want to isolate the square root. So my first task will be to move this plus 2. I'm going to subtract 2 on both sides. So now I have 2x minus 2 equals the square root of x minus 1. Now that I've isolated the variable, it's time to square both sides. Ooh, remember here that this really means 2x minus 2 times 2x minus 2. So however way you want to do that, that's fine. So I'd get 4x squared minus 4x minus 4x plus 4. They just combine like terms, so we'd get 4x squared minus 8x plus 4 equals x minus 1. So here's another example. We had a radical equation. It just turned into a quadratic equation, which is fine. I'm going to set it equal to 0. So I have 4x squared minus 9x plus 5 equals 0. We could try to factor it, but we could also use a method that will always work, and that's the quadratic formula. So I'm going to try that. So x equals negative b, so in that case I'll put positive 9, plus or minus the square root of negative 9 all squared, minus 4 times a, which is 4, times c, which is 5, all over 2 times 4. Now I'm just going to simplify. So we have 9 plus or minus the square root. That's 81. Let's see, 16 times 5 is minus 80. Divide by 8. And the 81 minus 80 is 1. So if you used your calculator, hopefully you went right to the 1. And the square root of 1 is 1. So we have 9 plus or minus 1 over 8. I'm just going to split those into the two answers you could get there. So 9 plus 1 over 8, which is 10 over 8, or 9 minus 1 over 8, which is 8 over 8, which is 1. Okay. So now remember, you want to check and see which of these answers are correct. Remember, none of them might be correct, or both of them might be correct. It's all about the intersections. I'll just do a quick sketch of the intersections over here to show you what I'm talking about. So the graph of 2x goes through 0, 0, slope of 2. Looks like that. And then graphing the radical, that was moved right 1 and up 2, which looks like that. So you can tell they intersect right there at 1. I'm not even going to do the check. We know that there's only one solution, and this is it. So I'll cross this out. I'll just write EXT for extraneous solution, just so I know that I make a note of that. And our only solution is x equals 1. Alright, good luck on your practice.